Good afternoon and welcome to our live session this afternoon. We're here to help you this afternoon to do your maths problems, and if you have any questions you can dial the number that you'll see on your screen, 0861 058 262, and we'll be helping you with those questions in a little while. To kick off this afternoon, we're going to have a look at a problem which we've already prepared for you, and you'll see it on your screen and we'll go through it together at this stage. Right, let's have a look at the question. It says, the Royal Bafokeng Stadium is one of the stadiums that will be used during the 2010 Soccer World Cup. It has a seating capacity of 42,000. The stadium will be used for 5 first-round matches and 1 second-round match. The seating categories are based on the position of the seat in the stadium. Category 1 seats have the best view of the soccer field, as indicated on the diagram alongside. And you can see that they've listed the different categories 1 through to 4 on the stadium picture. Let's have a look at the question. 3.1 gives us a table, and it says that the table below gives the ticket prices for South African residents for the various types of matches and categories of seating. You can see that we've got the type of match on the left-hand column, and then the different categories are listed there from category 1s, 2, 3 up to 4. The 2 stars there indicate that these are wheelchair-bound spectators that pay for those tickets only. So we've got the opening category and its prices, the first round matches and its prices, second round and its prices, and so on right through to the final. If you remember, the question said that we're only going to be interested in first round and second round matches for this stadium. So we'll only be looking at the 2 columns or rows over here for the first round and for the second round. Now, the first question, 3.1.1, asks us to write down a formula in the form total income that can be used to calculate the total income from the ticket sales for a second round match. Now, of course, this is not a formula that you will just find in your maths textbook. It's not something that you've learnt. It's not something that you've had to memorize. You've got to create this formula by understanding how we get to that total income. So let's have a look quickly and see what we can do. Remember, the total income, let's just get our pen. Here we go. The total income it's made up of all the tickets and the different categories of those tickets multiplied by the number of people that come to each of those matches in the different categories. So what we've got to do is we've got to say we want the number of people multiplied by the price per category. So let's start off here. Total income will equal category 1 price times number of people. Now, let's put that into brackets, because we've got to add each of the different categories for the different categories that we have. We've only done category 1 here. We've got to do the same thing for category 2, 3, and 4. So we're going to add, and we'll open a new bracket, category 2, price, multiplied by number of people. And of course, we've got to do the same for category 3, number of people, and let's just scroll down a little further, plus the last one, category 4, price, multiplied by the number of people. That will give us our total income. Now, don't be afraid of such a long formula. It is a long formula, but you've covered all your bases now. You've covered the different categories and the number of people that will attend each of those categories, and this will then give you the total income. If we go back to the question, we're just going to go look back there quickly and see it says, We only had to write down the formula. Notice they didn't ask us to actually work out what the answer was in this first part. So you're getting your 3 marks in this case simply for realizing all the information that is on that chart in your formula. Let's move on to the second question. 3.1.2 says, the following table shows the expected number of tickets to be sold in each category for the second round match at the Royal Bafokeng Stadium. You can see here they've listed in this table category 1 through 4 again, and they've given us the different numbers of the people that they expect to come and attend those matches. Now, question A says we want to calculate the Royal Bafokeng Stadium's expected income from the sale of these tickets. Well, now we're going to actually use that formula that we wrote down at the beginning, because we'll need to now put in the category prices as well as the number of people which they've given us on our table over here. So let's do that quickly. All right, category 1 has got 12,425 people. So that's 12,425, and we've got to multiply that figure by the price of a ticket. Let's go and check quickly what that was again. Remember, we're interested in the second round match. So that's over here. Second round match for category 1 is 1,400 Rand. So we're going to multiply by 1,400. Next, we're going to add the number of people in category 2, and that was given to us as 8,672. So that's 8,672, and of course we've got to multiply that again by the number of people, by the price of the ticket. And in category 2, a ticket cost 1,050 Rand. So we'll go and put that in over there. Next, we're going to do category 3. And if we have a look, the number of people that attended category 3 was 4,546. 4,546. And we again need the price for category 3 in the second round. That's 700 Rand per ticket. And lastly, we're going to find the number of people expected to attend category 4. And that was 14,424. 14,424. And lastly, the price for those tickets went at second round 350 Rand. Remember, when you're answering the question and you're busy filling in all the information, be very careful. Read the information carefully. It's very easy to use the wrong match. For example, you could have looked at the wrong figure and perhaps taken the first round match instead of the second round. It's always useful in the exam to spend that extra 30 seconds or 1 minute just to make sure that you've used the right figures. We're going to go on now to calculate the answer, and for that we're going to need our calculator. It's 14,424 is what we need to put in. Let's just quickly check that. We had 5 over here. Let's just cross that out. It's 14,424. If you go back and have a look at the question, it does say 5 there, but we'll use 424 just for our answer for this stage. Right, let's add up the answers now with our calculator. Sorry, let's just fix that quickly. It was this one that needed the change, and there we go. This one must still be the 5. Right, here we go. And 14,425 multiplied by, and we needed, let's just check there, 1,400. So that bracket gives us an answer of, a rather large answer, 20,195,000. Let's put that in, 20,195,000. And then we're going to do the second bracket. That has 8,672 people. and we're multiplying that by the ticket price, 1,050. That bracket, 9,104,550. The third bracket is 4,546. 4,546 multiplied by 700 for these tickets. And there we go. Answer there is 3,182,200. 3,182,200. And the last bracket, we need 14,424. And we're multiplying by the ticket price of 350 Rand. And there we get an answer of 5,048,400. So that's 5,048,400. Well, that leaves us just to add up all of these answers. I'm going to quickly do that. We've already got the 5 million. Let's add the 3 million. So plus 3,182,200. And then we're going to add the 9,104,550. And our last figure was, let's just check it here, 20,195,000. 20,195,000. And our total income here will be 37,530,150. 37,500,000, let's copy it down correctly, 530,150. And of course, remember, don't forget your units at the end. We must put in the Rand sign. All right, we've got a couple of minutes. We can maybe... Just before the break, we had a question which we're going to continue with, following on from our question on the Bafokeng Stadium and calculating the total income. Let's quickly have a look at that question. Remember, the stadium seats 42,000, and we were asked, because the organizers wanted to allow the mining company to buy up the rest of the tickets and sell them at a reduced cost or give them away. Now, the question asks us, let's have a look here quickly. It says that the organizers and the mining company agree that the reduced ticket price should be 48% of the average ticket price of a Category 3 and Category 4 seat for the second round. Well, let's start by calculating what that average is, and then we'll go and have a look at how many tickets they will actually need to purchase to fill up the stadium. If we go back to the top here, and this is where we were given our prices. Remember, it's for a second round match, and we're interested in the price of a third category seat or in a fourth category seat. In other words, the 700 and the 350. Now, to calculate the mean, we've got to add up those two figures and divide by the total number of figures that we have, which in this case is 2. So let's go ahead and do that. I'm just going to move our screen down a little bit. A ticket price for category 3 was 700. A ticket price for category 4 was 350. To calculate the mean, we add those and divide by 2. If we go to our calculator, let's just clear away the last sum. We've got 700 plus the 350, and that equals 1,050 divided by the 2. We can see that the average price for these tickets is 525 Rand. So that's 525. That's the mean that we need. Now, what we're also going to need is we're going to have to find out how many people they can sell these tickets to, or to fill up the stadium. We've been given here in this table 5 the number of people that are expected to come and attend these matches. So we're going to have to add up all 4 categories to get a total, and then subtract it from the seating capacity, which you can see over here was 42,000. That will tell us how many tickets are available to be sold to this mining company. So let's do that quickly. Again, we're going to need our calculator. I'm going to do it over here, seeing that I've got the figures right by me. 12,000, sorry, let's just check that figure, 12,425. There we go, 12,425. Added the number of people from category 2, 8,672. Plus category 3, 4,546. And lastly, in the category 4, we've got 14,424. And that gives us a grand total of 40,067 people. I'm going to go and write that on my answer sheet, 40,067. Now remember, to fill up the stadium, we'll have to get to 42,000. So we want to subtract this answer from the 42,000. So we're going to say 42,000 subtract 40,067. And if we go to our calculator again, let's do that. 42,000 subtract 40,067. That gives us 1,933 seats left. So our mining company now are able to buy 1,933 seats at this average price of the category 3 and the category 4 tickets. The question goes on to say the organizers and the mining company agree that the reduced ticket price should be 48% of the average. So we're not just going to multiply those two figures together. We've still got to do a further calculation first. Let's go back to our answer here. We had 525 Rand as the average, but we actually want to work out 48% of that 525 Rand. So let's do that quickly as well, and we're going to say 525 multiplied by 48%. Now remember, to calculate 48% on your calculator, you say 48 divided by 100. Let's go and do that, and then we can work out this price. It's 48 divided by 100, and that gives you 0.48 if you convert it to decimals. And we're going to multiply that price by the 525, which was our average of the two category 3 and category 4 tickets, and that gives us an answer of 252 Rand. So what the mining company are being offered is a ticket price of 252 Rand, and they're being offered 1,933 seats. The question then goes on to say that we are to calculate the additional income that could be obtained from the sale of these tickets. So we're going to sell these tickets to this mining company at 252 Rand, and we're going to sell 1,933 of them. Let's go and work out that last calculation. So it's 252 multiplied by the total number that are available, 1,933. Again, we'll have to go to our calculator to work out this one. There we've got our 252 already. We multiply by 1,933. That gives us a total of 487,116. 487,116. And again, remember, that's rands. So the mining company, by buying up all of these tickets, will bring in for the Bafokeng Stadium a further 487,116 Rand, in addition to that very large figure that we calculated earlier of around 37 million. And that will ensure that they now have a full stadium, because every ticket or every seat is accounted for.
My name is Peter, and I'm going to spend a bit of time with you this afternoon looking at the exciting world of mathematical literacy. And I say it's exciting because the subject of mathematical literacy is based on real-life scenarios. None of this X and Y and Z and all that rubbish that you get in mathematics, but real-life stuff. Now, we've been waiting for your calls, and as yet, we haven't had many. So what we're going to do in the meantime is I'm going to look at a question, and we're going to discuss it and try and make sense of this question. Let's have a look at it. Here we go. A Mr. LaRue publishes children's books. Initially, he published the children's books only in English. He now intends to translate the books into other official South African languages. The bar graph below, here it is, shows the percentage distribution of the South African population according to official language groups. The population of South Africa was approximately 47,900,000 in 2009. So, let's have a look at this. We have a guy here called Mr. LaRue. And Mr. LaRue decides he's going to publish some books. But he does a very, very silly thing here. He only publishes them in English. Now, if we were to look at this graph down here, there we go, we can see that South African population is actually made up of more languages than just English. In fact, from our graph, we can see that English only makes up 8.6 what? Percent. So our axis on the left is all to do with percentages. Now, before we go into the question, let's analyze this actual graph. We can see we've got various intervals. We've got 5, 10, 15, 20, which means every individual little line over here is actually 1%. 1%, 2, 3, 4, and 5, etc. Over here, we can see we've got a various number of languages. Again, our fella, he publishes some books. Only 8.6% of these books are in English. But look here, we have a subject like isiZulu, which makes up 23.8% of the population speak the language. What about Afrikaans? There are more Afrikaans-speaking people in South Africa than English. Well, according to this graph anyway. So now, now that we've analyzed the graph, let's answer some of the questions. Now, one thing I want to stress right now, listen carefully. This is a paper 1. Okay? Now, you know mathematical literacy is made up of paper 1 and a paper 2. Now, we tend to say, but we don't like to say it too loudly, but we tend to say that paper 1 is your easier paper. In other words, there are not going to be some weird and tricky questions in here. They're going to be simple, straightforward, and hopefully we're all going to be able to do very well in this paper. So, by that, this is what I mean. Let's have a look here at question 2.11. 2.11 says this: which official language is spoken by the largest percentage of South Africa's population? Now, this question is only worth 1 mark. No trick, nothing to worry about, nothing to panic about. In fact, a wonderful question to boost our confidence. Let's look at the graph. Which graph is the highest? Here it is. Nothing hard, nothing difficult. isiZulu, 23.8%. Full marks, 1 out of 1. We're already on 100% and we've just got started. Question 2.12. Now it says use the graph to list the official languages that are used by less than 5% of our population. Let's look at the graph again. Looking at it, here's our 5% line. We're wanting to know now what graph is below this 5%. Well, Afrikaans is way over the top. English is over the top. Here we go. Isi Ndebele, 1.5%. That is one of our answers right here. Okay, there she is. Another one, here we go. Another one, all below 5%. Again, folk, there's nothing hard here. There's nothing difficult. Straightforward, easy marks, boosting our confidence. Let's go on to the next question. It's exciting stuff. 2.13. What percentage of the population uses Siswati as an official language? All right, back to our graph. We can see here, we're looking for Siswati. Here it is here. I'm just going to get rid of all these things. Okay, there we go, because we've scribbled all over our graph. Now, this is what we're interested in. What percentage of the population does this language make? Well, let's have a look at it. We look here, all our graphs have figures on top. And we look here and we say, oh my giddy aunt, we got a problem. There's no figure here. How are we going to find this figure? Straightforward again. Because we're dealing with percentages, we know percentage means out of 100. So if we look at Afrikaans, we've got 14.3 out of 100. We've got 8.6 out of 100. We've got 1.5 out of 100. Okay? So what we're going to do is we are going to say, all right, if all of these are out of 100, when I look at my total, 14.3, 8.6, 1.5, 17.6, 23, etc., 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 all those figures should add up to 100. But when we do add them, and I'm not going to do it now, you can do it on your calculator at home, but when I add these up, 14.3 plus 8.6, 1.5, and all the rest, I get less than 100. In fact, I get something like 97.3. So, if I get 97.3, I know that this Siswati is going to be 100 minus that 97.3, and I'm going to get that answer right over there. Straightforward, simple, nothing to worry about. Let's move on. Now it says, calculate the number of South Africans that use English as an official language. All right, so back to our graph. We know that 8.6% of the country use English. So I'm going to go here, and I'm going to say, right, I have 8, let's just find our pen, I have 8,6%. Now, another way of writing a percent is over 100. We know this. You've been taught this over and over again. So I'm not going to write 8,6%. I'm going to write 8,6 over 100 of my population. And of means times, doesn't it? So we're going to say of the population. Well, what is my population? Let's go and have a look at the question again. We're going to go right to the top, and there she is there. 47,900,000. So our population, 47,900,000. Big number, nearly ran out of ink. Equals, we find our calculator, because I'm not going to do that in my head. 8, let's go for it, 8.6 over, what did we say, 100, why? Because it's a percentage, multiplied, let's just delete that, multiplied by 47,900,000 equals, and voila, there's our answer, 411,9400. In other words, 4,119,400. Now, I want to tell you something. This afternoon, or earlier today, I did this very question with a group of my matrics. And one of my boys turned around and said, "Hey, I didn't get that answer. In fact, I got this answer back at the screen. He got 4,194,000. 41,190,000. And I just said, whoa, let's just stop. Mathematical literacy makes sense. So if I were to say to you, what is 10% of 47 million? You would say, well, it's 4.7 million. So surely 8.6% must be less than 4.7 million. And that's exactly what we got over here, 4 million. None of this 41 million rubbish. That's just unacceptable. Okay, right, back to our question. And we're scrolling down. Now, it goes on to say, suppose Mr. LaRue decides to print 100,000 copies of a particular book. Use the graph above to calculate how many of these books should actually be printed. Okay. And he wants them printed in isiXhosa. So we're saying this. He's got 100,000 books. He's not going to print a book for every single person in the country. That's ridiculous. First of all, because not every single person in the country is a kid. And second of all, not every kid reads the same book. So it would be pathetic to print 47,900,000 books. He's only going to print 100,000. Okay? But how many of those books are we going to print in isiXhosa? Well, let's have a look. We know that this guy is printing 100,000. Okay? So he's got 100,000. Let's go here. 100,000 books. That's all. Now, of that, he's printing a certain percentage. And that percentage is, if we go and look at our graph, okay, here it is here, 17.6%. So we only want 17.6% of our 100,000. And we do that basically with a calculator. We say 17.6 over 100, multiply it by 100,000, and we're going to get the number of books that is printed in Xhosa. Folk, we're going to take another break. If you've just tuned in, we're busy with mathematical literacy. In fact, we've just had so much fun in the last session, we've decided to do another question. So let's have a look at a new question. This is a little bit about space and measurement, so slightly different content, but just as exciting. In fact, I think even more exciting. Let's have a look. The question reads, a circular glass top, a tabletop, is cut from a square piece of glass. That is 136 centimeters by 136 centimeters, as shown in the picture below. Well, it's actually not below, it's on the side of it, but who's complaining? The length of the radius of the circle is 68 centimeters. A flexible aluminium strip is attached to the circular edge of the tabletop to form an edging. All right, let's talk about this question. Now, we have decided to buy a piece of glass to make a tabletop, right? And so let's pretend my wife says this to me. She says to me, Pete, we want a table, it must be out of glass, and I want it round. You go get the glass. So off I go, because I'm an obedient kind of guy. So off I go, running along, get to a glass company called Shatterproof or PG Glass or Tinkle Smash, whatever it is. We get there to this glass company, and I say, I want a round piece of glass. First thing the guy's going to say to me is, what size do you want? Now, of course, I would have forgotten, so I would have run home, measured, and then come back and said, right, now I know what it is. It must have a radius of 68 centimeters. And so the guy brings out a piece of glass. But it's not round. It's a square piece of glass, which confuses me totally. Let's have a look at the question. Let's look down here. Here it is. My circular piece of glass, that's what I want, but I get a square piece. I told him it must have a radius of 68 centimeters, and there it is over there. So this is the context of the question. Round piece of glass must be cut out of a square piece of glass. Added to the confusion, the wife says we can't just have glass around the edge of this table. We've got to have a piece of flexible aluminium. Now, only a woman would want to know why she wants a flexible piece of aluminium around the glass, and we're not going to complain, we're going to do it. So that's the context of the question. Now, let's look at the question. Before the question even starts, the examiner in this question is a phenomenal chap. Brilliant guy. Why? Because he's helping us. He's helping us unbelievably. In fact, before we even start the question, he says this. Let's have a look here. He says, note, units of measurement must be indicated in this question. In other words, folk, if I'm dealing in area, I must deal with centimeters squared. If I'm dealing in volume, I must deal in centimeters cubed. And the examiner is helping me, saying, oi, don't forget this. So we're not going to forget it. Let's look at the question, 2.21. What is the length of the diameter of the table? Now, for those of you who weren't tuned in before the ad break, I said that we are taking questions at the moment from a paper 1. So there's nothing difficult about it. There's nothing complicated about this question. In fact, we're expecting it to be nice, simple, and straightforward. And this question is only worth 1 mark. So there's no trick. What is the length of the diameter of the table? Well, we know the radius is 68 centimeters. And if the radius is 68 centimeters, the diameter must be twice that. Because, and I'm going to do it in a nice color blue here, and if I had a ruler, it would be a very straight line. But that is my diameter, 68 over there, and a further 68 centimeters over here, making a diameter of 136 centimeters. Don't forget the units, we were warned about that. Question 2.2 says the following. Calculate the perimeter of the square piece of glass. Okay, so we want the perimeter. What does perimeter mean? Perimeter means basically this, that if I had a shape and I put a little ant on the one corner, okay, back to our drawing. If I put an ant over here and I gave him strict instructions to follow that line, the ant would walk from this cross all the way to that corner, down to this corner, across back to this corner, and back up to the X. And once he got there, we'd squash him because we wouldn't have any need for him anymore. But we would then measure the distance he'd walked. And we would say, well, that's 136 centimeters, plus 136 centimeters, plus 136, plus 136. And we'd get a lot of centimeters, okay? But what happens if I didn't quite understand what perimeter was? Well, the examiner of this paper is even nice. In fact, if you meet him one day, give him a heck of a hug. Why? Because, let's back to the question. He says, use the formula. And he gives us a formula. Now, everyone, look me in the eyes. Camera, over here. We need to understand the following. No examiner wakes up at 2 o'clock in the morning or 3 o'clock in the morning and says, let me think of a formula and just slap it into a question and confuse the nation. There's no point in that. So if you get given a formula in a question, you're going to use it. And if you don't use it, chances are you could have made a mistake. Back to our question. So it says here, use the formula. Perimeter of a square is 4 times the length of a side. How long is my side? 136 centimeters. So we are going to say we've got 4 times, and I'm just writing it here, 136 centimeters. I'm going to try and write it there, okay, times 136 centimeters. And we just do that on our calculator, and we get the answer. Okay. Next question. Calculate the area in centimeters squared. Let's get rid of some of this. Calculate the area of the glass top table. So here's our glass top table. Remember, we had a square piece. We've cut all this stuff away. Let's get rid of it. Here we go, in red. We've got rid of all this stuff. We don't need it. Why? Because if I came home with a square piece of glass, my wife would smash it over my head. She wanted a round piece. So I've asked them to cut it. That's what I've got. And the question now says, calculate the area of that. So that's what we're going to do. Again, examiner's nice to us. He gives us the formula. He's given it to us, use it. Let's have a look. Area of a circle equals pi times radius squared. And then it goes on to say, using pi as 3,14. Now, let's just have a look at our calculator. Our calculator has a pi function. There it is there. So if I push shift pi on my calculator, it shows me pi. But my question says, no. You're not using pi. Why are you not using pi? You're not using pi because some people don't have pi on their calculator. They've got a very basic calculator. So to make sure we all use the same value, let's use this value. And here it is over there, 3,14. So on my calculator now, instead of that pi, I'm going to write 3.14 times my radius. What is my radius? It's 68 centimeters. So times 68, but folk, it does say squared. And you know I'm involved with marking matric papers. And man, it gets so frustrating when people say pi times 68 and they forget to square the 68. Folk, paper one, you've got so much time. Relax, sit back, enjoy the paper. And don't make silly mistakes. It's easy marks. Make sure you get them. And by forgetting to square a value, you're just throwing the marks away. So, back to our question. Here we are on the calculator. Times 68, and we're going to square that answer, or square the 68. And we say equals, and voila, we get a wacko answer, and it's actually 14,519,36 what? Centimeters squared, because we're dealing in area. Area is always squared. And while I've got you here, volume cubed. So area squared, volume cubed. Don't forget that. Write it on your wall. Stick it on your TV. When your folks try and watch TV tonight, let them see volume equals cubed. Area equals squared. Teach your folks maths. Right. So let's move on. The next question goes on to say the following. Calculate the circumference of the glass tabletop. Using the formula, circumference of a circle is 2 times pi times r. Do you remember when my wife told me that she wants a piece of aluminium around the glass? And we don't understand why she wants that, but she wants that, so we're going to do it. So now we need to say, well, how long must this piece of aluminium be? Because obviously it's got to be pretty long, and then we're going to wrap it around the table. It doesn't come in round pieces, it's one long piece. And so we need to say, well, how long must that piece be? And when we calculate the length of a circle, we call that our circumference. So let's have a look. We need to calculate the circumference of a circle. Again, folk, examiner, fantastic guy. He gives us the formula, and he tells us quite clearly that the circumference of a circle is equal to 2 times pi times radius, where pi again, 3.14. So we're going to push 2 times pi times, what's my radius again? 68. And we just slap that into our calculator, and that'll do all the work. And that's just another thing. Again, camera, focus, let's look. You've got a calculator. If you've got a calculator, let's use the calculator. Okay? I always say to my students, not bringing a calculator to maths is like playing hockey without a hockey stick. It's dangerous, it's silly, and someone's going to get hurt. And if you come to my class and you don't have a calculator, you're going to get hurt. Not because I'm going to hurt you, but your marks are going to get hurt. You got a calculator, use it. It will think for you. So, back to our question once again. Now we've got this aluminium strip. We're told it costs us 54 cents for every centimeter we buy. And we're going to calculate the cost in rand for 425 centimeters. So we've got 425 centimeters. Let me just find another little blank screen. Here we go. We got 425 centimeters. And we know that each centimeter cost us 54 cents. So we're going to times it by 54 cents. Now, I am going to do this on the calculator for a specific reason. So we've got 425. We're going to multiply it by our 54 cents, and we get an answer here of 22950. What? Cents. Why? Because that's what we're calculating. Now, folk, if I go shopping and I go off to some shopping center and I look at the price of something, I don't look at the price and see, hey, you know what? Something costs 3,421 cents. No, it's always in rands and cents. Let's go back to our question. So basically what I'm saying is this figure needs to be changed into rands and cents. How do we do that? We divide it by 100. So my answer is actually going to be 229 Rand and 50 cents. But in case you didn't know that, the examiner actually helped you along. He said in rands. He didn't have to, but he did. Why? He's a great guy. I'm looking forward to meeting this guy. Folk, I'm having so much fun, but we're going to take another break.
We have Pendile. Pendile, can you hear me? Hello, is Pendile there?
Hi.
Hello, can you hear me, Pendile?
Yes, I can.
I believe you want some help today with conversions.
Yes.
All right, well, do you have any specific question that you want to ask, or can I just give you some examples?
Please give me examples because I don't have any question papers with me.
Okay, all right. We'll go and have a look at some examples. If you watch on your screen, you'll be able to see what we're answering as we work through this. Now,
Okay.
with conversions, let's start off with a simple one. For example, centimeters to meters. I think that's a nice one to start off with. Now, remember,
Okay.
with any value, okay, if they give you a value with a certain unit and they tell you that it has to convert to another unit, it's important that you know how many of the one unit are in the unit that you are converting to. So let's take
Okay.
an example. If I've got maybe 540 centimeters, let's start with that. 540 centimeters, and the question is asking us just to simply convert that answer to meters. So we want our answer in meters. We don't know how many meters is 540 centimeters is, but we want to convert it. Well, we need to know the ratio of the conversion. Do you know how many centimeters are in 1 meter? Pendile?
That's what I always struggle with.
Sorry?
I always struggle with that. I get confused. I don't know whether it's 1,000 or 100.
Okay, well, it's 100. That's right, it's 100. So you need
Okay.
to know that there are 100 centimeters are equal to 1 meter. So we've got 540 centimeters. We already know that 100 centimeters equals 1 centimeter. Oh, sorry, 1
Okay.
meter. Now, to convert, what we've got to do, tell me, is the centimeters a larger value or is the meters the larger value? Which one is bigger? It's just as a number.
Meters.
The centimeters is bigger, yes. You can see that the meters is only 1 meter, okay, because we've gone to a unit where it's actually a smaller number because the unit itself is bigger. So obviously my answer for the meters, for the 540 centimeters, has to also then be a smaller value. Well, how do we turn 100 into the value 1? What do we do to get 100 to make it a 1? We divide by... How will I turn this value 100 into 1? If I divide by what?
Divided by 100.
Yes, if I divide by 100, remember, if I'm dividing by any value which is the same at the top as it is at the bottom, the answer for that is always 1. So to get from 100 to 1, I've got to divide by 100. We did that there, so we've got to do the same thing here at the top. We're going to divide the 540 also by 100, and that will give me my answer in meters. And if you're not sure, of course, you've got a calculator which you can use. So let's turn to the calculator quickly. We're going to type 540, and we're going to divide...
5,4.
Sorry,
Get
Pendile?
5,4.
It's going to be 5,4, correct, that's right. Okay, there we go. So you can see they did it as a fraction first, but there as a decimal, it's 5,4. And you can see that the value there has become much smaller than the 540. All right, let's look at another example quickly. One of the more difficult ones to do always involves time, okay? And sometimes I'll ask you something like, work out what is 0,5 of an hour, okay? Let's do that one quickly. How many minutes is that? 0,5 hours equals how many minutes? Well, if it's 0,5 hours and we want to go to minutes, okay, are there more minutes in an hour or are there more hours in a minute? Which has got the bigger value usually? Do you know how many minutes?
May you please repeat?
Sorry?
May you please repeat that?
I just missed that, Pendile, but you want to know are there more minutes in an hour?
Okay.
Yes, there are, okay. So do you know how many minutes there are in an hour?
Yes.
How many?
In an hour, there's how many minutes?
That's
in an hour, 60 minutes.
That's right. There are 60 minutes in an hour. And you see, this is where sometimes people get confused. They think 0,5 hours. Oh, that must mean 50 minutes, okay? Does that equal 50 minutes? That's what often my students do this. They write this in their exam papers. They see 0,5 and they think, okay, that means 50 minutes. But that's not correct, okay? Incorrect. We don't do that because we've got to remember that the conversion for 1 hour is equal to 60 minutes. So what I want to know now is what is 0,5 hours equals how many minutes? Can you hear me still, Pendile?
Yes. Isn't it 30?
Well, we want to turn 0,5 into how many? What is 0,5 as a fraction? 0,5 out of 1 is what? It's a, do you know there's a fraction? It's a half. Very good. Okay. We can do it on the calculator. 0,5 divided by 1. Okay, there it is. It's a half. So what we're actually looking for here in this answer is we want to know what is half an hour. Half an hour. 0,5 is a half an hour. And what did we do to turn 1 into 0,5? We divided by? Well, what do we divide by to get to 0,5 from the 1 hour? 1 divided by 2. That's what a half is. Remember, when you see a fraction, it's always that line means division. It's 1 divided by 2. That's what the fraction means. So what we're going to have to go and do now is say, well, we want to divide our hours, our minutes. Also, we want to know what over 60, okay, is going to give us that 0,5. So we've already got the 1 out of 2 is equal to what out of 60? Not out of 100, remember, because there are 60 minutes. So how much, what's going to have to go on the top? Well, 2 times what equals 60? Do you know?
30.
That's right. Okay, we multiplied by 30 at the bottom. But if we do it at the bottom, we must also do it at the top of the fraction. So 1 times, we also multiply by 30. And what's 1 times 30?
30.
It's 30. Okay, so we know now that a half an hour, okay, or 0.5 of an hour is going to be 30 minutes. All right, let's fill it in there. 30 minutes. All right, remember when you're working with time, it's a very important conversion. You need to make sure that you divide or work with a 60, not with 100. It's very easy to make the mistake and to use 100 and say 0.5, oh, that means 50 minutes. But no, it's not. It's only 30 minutes because we're working with a fraction of 60 or out of 60. Okay, let's quickly look at one other quick conversion. We've got a few more moments. We can just do another one. Sometimes they like to give you these odd measurements. Have you seen, for example, they ask you to convert things like pounds to kilograms? Have you seen that come up in some of your examples?
Yes.
You have. Okay. Well, again, they'll usually give you what 1 kilogram is in relation to pounds. And let's have a look quickly. Here's the usual conversion. They'll say 1 kilogram is equal to 2,2 pounds. And the sign for pounds is LB. Okay, that's how they give it in an exam question. Now, they might say to you, work out how much is 35 kilograms in pounds. Okay, so we've got 35 kilograms that we want to know, and we want to know how many pounds is that. Okay, well, we know again, you see, you've got all the answers except for the one that you're looking for. We know 1 kilogram is 2,2 pounds. Well, how do we go from 1 kilogram to 35 kilograms? What did we multiply by to get to 35?
2,2.
No, hang on. We don't want to just multiply by 2,2. We're going to go from 1 times what is 35? 1 times?
Please repeat that.
I'm saying if I'm just looking down, I converted, I multiplied by 35 to get to 35 kilograms. Do you agree? From 1 kilogram to get to 35 kilograms, we've got to multiply by 35. We can do the same on the other side. We can say 2,2 multiplied by 35. Okay, and that will give us our answer. Now, you said we should take the 35 and multiply it by 2,2. Well, that's another way to look at it, because we could have also said here, if we're looking across our calculation, to go from 1 to 2,2, we multiply by 2,2.
So 2,2.
That's right, okay. Then let's just put my earpiece in here again. It's just gone, so I can hear you properly. So if we wanted to do that across as well, we could have gone here, multiply by 2,2. So either way is acceptable, Pendile. You can either do the multiplication to say how I convert this number down to that number, and then you do the same on the other side, or you can do it across and say how did I get from this number to that number, and then you can do the same calculation at the bottom. All right, so let's quickly have a look at that answer, and we're going to say that's 35. Let's do your one, which was 2.2. Okay. Right, and we're going to multiply that quickly. That gives us 77. All right, so let's give that answer there. So to answer the question, to convert the kilograms into the pounds, 35 kilograms would actually be 77 pounds. Are you happy with that, Pendile?
Yes.
All right, does that help you a little bit with conversions?
Yes.
Now, just
It helped me a lot, it seems.
for the exams, when you're busy in the exams, write down the conversion that they give you, okay? Put your number that they give you at the top, and then do the one that they're asking you for underneath, and ask how the numbers relate. You see, again, if you write them out like this, you can see nicely, I've got to convert that number to that number I must multiply by. Sometimes it might be a multiplication, and sometimes it might be a division, depending on whether you're going from a large number to a small number, or from a small number to a large number. Okay, but write it out like this. It's important that you do that. That will help you to see how the two ratios or conversions relate to each other. Good. I hope that helps you.
Yeah, thank you,
And
bye.
all the best for your exams, Pendile.
Thank you so much, bye.
Super. Thanks for phoning.
learners. I hope you are well. Presenters did come and try to show you some of the questions. I'll be continue trying to help you with our mathematical literacy. We know it's a very practical subject, so we are really not going to stress about it. I've took a question from the prelim. It's very recent. I hope you still remember it. It's question 3.1. A cell phone supplier interviewed all phone users in order to determine which age groups use a prepaid option or had a contract. 500 cell phone users per age group were questioned. The following compound bar graph displays the result. Now, if you observed earlier, the second presenter showed you a bar graph. So this one is different. We call it a horizontal bar graph because it goes to the side. So we have two types. The other one goes up, which we call the vertical. The other one goes to the side, which we call the vertical. Now, the information that we have been given is very, very crucial. They say 500 cell phone users. So you must remember that. So the first question says, determine the number of prepaid users in the age group 15 to 19 years. Now, how do you get the answer? You go back to your graph. If you look into your graph, you've got different age groups on the y-axis. On the x-axis, you've got the percentage. Remember, this is not just any number, it's a percentage. You'll realize today we're working a lot with percentage here because that's what Maths Lit is all about. Now, look, they say the age group 15 to 19 years. So you look on your y-axis. This one is under 12, 13 to 14. Now you go to the one for 15 to 19 years. So that's exactly where you are. So to approach this question, you will simply say, prepaid. Now you have been given something that is very important here. If you look into your graph, you have what we call the key. This darker side is the contract option, and we've got the prepaid. So because we'll be dealing with 15 to 19 years, you'll say, my prepaid. So where do you go in the 15 to 19? Yeah, there you are, 55%. How do you approach it? Very simple. You simply say, 15 to 19, here you are. This is the 55. Then you say, 55% of 500. Now, where did I get this 500? You got the 500 because they said each age group was given 5 people. So you use that 500. Let me write it here so that you can see it clearly. So you use that number, which is 55% of 500. Now, we already know 55%. Guys, this is mathematical literacy. Do not stress. You have got your calculator. You simply go to your calculator. What you need to remember is very crucial, and you've been already told that numerous time. Of means multiply. So what do? You go to your calculator. You make sure that it's on. Then you simply say 55. You go to shift, and there it's your percentage. And your of, it's multiply, then it's 500 equals to, you get your answer, which is 275. You don't just say 275 because the question said, if you go up there, determine the number of prepaid users. So you must answer definitely in full and say 275 users. Because we don't know, is it dogs? We need to know exactly what you're talking about. So we go into question number 2. Determine the number of contract users. Now look at the difference. The first one, it was prepaid. And remember, a bar graph always has got the keynote. So your keynote has got the contract option and the prepaid option. Now you go to the second one, it says the contract option. So, and please look at this question very, very carefully. It says to you that are 20 years or older. Now you go back to your graph and say, okay, 20 years. Now, when you look into your graph, which ones are 20 years and older? So it means anyone above 20 years. So what you simply do, you say, okay, 20 years, they fall within this range. So it's 20 to 24. Over 24, they also fall within that range. So this one, when you approach it, it's 3.1.2. So this one, when you approach it, you say, okay, what is the percentage? Firstly, so how you say 20 to 24 years. So you come here because it's above 20. So it's going to be 20 to 24 years plus, please don't forget that because it's very, very crucial, plus over 24. So when it's over 24, you also add it here. Plus over 24, remember it's over 24. So you go back to your graph. It's very simple now. Remember the question back. It says the contract users. So you go back to your, you say, okay, my contract, it has got this color, so I'm going to use the one on the top. So here, remember, it's given in percentages. So it means you are going to find the percentage of this one. So you quickly come here. You keep, and you say 84% is the same number, which is 500. Plus, you quickly go there. Remember, you are working on time. You quickly go there and say, okay, over 24, 95%. You come back. Let me quickly get it. It was 95%. So you say, okay, 95% of also 500. The most important thing that you need to remember, use your calculator. They said 84% of 500, you simply go there, 84. You go to shift percentage of 500. And then you say plus. To make it safe, just put them in the bracket. How many percentage? 95. You go to shift percent of also 500. And you've got, so the answer that you get, you simply write it there. So you have answered your question for 3.1.2. Remember, 20 years or older. The mistake that learners do, they'll just answer using this one. Remember, you must also go to that one because it's above 24. Why am I not going to 15 to 19? Because the question was saying 20 and above. So a person who's 25 years old is above 20 years. So you must always, always remember that. It is very, very crucial. Then you go to the 3.1.3, identify possible relationships or trends between the ages of prepaid users and contract users of cell phones. You go back. Guys, mathematical literacy is a very practical and applicable subject. So what you simply need to think of, a person who is under the age of 12, if you look here, the contract option, the percentage is less. The prepaid, the percentage is above. So when you, as you move up, this line, it keeps on getting smaller. So it means this is the trend. As they grow older, people as they grow older, they do not use the prepaid option, but instead they opt for the contract. So here, what is the trend? The trend is simply that the younger generation, they use the prepaid, and come on, it's common sense. They don't have money, they can afford those contracts. I mean, it's we parents who can really afford that. So, I mean, we are over 20, so you really go for a contract. So, if you look at the trend, the longer is the prepaid as it goes up. If you look at this one, as it comes down, it becomes smaller. So the trend simply there, you simply say the younger ones. So the younger ones, they go for prepaid. While the older ones, they go for contract. Please don't try to complicate it. It's very simple. It's straightforward. Just answer it the way you have been given. Now, so what is of very crucial importance that I want to really emphasize is, if you look in our graph that we have been given, it simply says to you here, what is of crucial importance that we need to remember when given a bar graph. Always, even when maybe you have been asked to plot a bar graph, or what if you are requested maybe to plot a bar graph and you are not being given this, you must always have the topic, you must always have the y-axis and the x-axis. You must always have the key. This is crucial. Now, you must always read the questions very, very carefully, because here it simply said to you, 500 cell phone usage per age group. So if you look here, you must look, I'm giving the percentages. So I'm trying to wrap up what I've been doing here so that you can really understand and you cannot be confused. It says prepaid users in the age 15 to 19. Here I said 55%. One can ask, where did you get that 55%? Here you have been given that 55%. So definitely you get everything from the graph. So that's simply it. You get everything from the graph, and you must remember it's your percentage. So you simply say 55% multiply because of then 500. Then you simply get your answer. I hope you did really get what we're trying to do here, because this is what we're trying to emphasize, and this is very, very crucial. The age group, the percentage, the key, the heading. Thank you very much for listening, and we'll take an ad break and we'll come back to you.
Hi guys, welcome back. For those of you who just tuned in, you're watching the maths literacy lessons today. We're looking at past paper questions, that is past papers 1 and paper 2 type questions. My name's Claire and I'd love to hear from you. So if you would like to contact us, you can get us on our number, which is 0861 058 262. Or if you want to email us at info@learnextra.co.za, we'd love to hear your questions. I'm going to have a look at question 3 from the supplementary paper from earlier in this year. So let's jump straight onto it. All right. The question says that it gives us a table. The South African Weather Service recorded the temperatures for 10 towns and cities in South Africa on the 13th of May in 2009. So table 5, what they've given to us, you can see they've given us each of the 10 different cities. You've got Bloemfontein, Cape Town, Durban, Johannesburg, Kimberley, Mafeking, Mzina, Nelspruit, Pretoria, and Polokwane. And in the table, they've given you the minimum temperatures as well as the maximum temperatures for each of those cities and towns. All right, let's go straight down to the question then. Okay, they ask us to use the information in Table 5 to answer the following questions. 3.1. The upper quartile for the minimum temperatures is 13 degrees Celsius. Identify the towns and cities of which the minimum temperatures were less than the upper quartile. Now, obviously, you need to think about, firstly, what are quartiles, all right? And so just take 2 minutes out, just have a look at that. Basically, what that means is that they've taken the information and they split it into 4 parts. You've got your top 25%, then you've kind of got your middle 50%, and then your bottom 25%. Okay, so what they're saying is that the upper quartile, the top 25%, is going to be over 13 degrees Celsius. Okay, so what they want us to do, they want us to have a look at the minimum temperatures and identify the towns and cities of which the minimum temperatures are less than that. Okay, so let's just jump straight to the table. So you can see here I'm looking at the minimum row, which is obviously those values, and we need to identify the towns and cities that are below 13. All right, so I'm just going to circle them. All right, so 5 degrees Celsius, that'll obviously be below 13 degrees. The 6, then we've got the 10, we've got 8, we've got 9, 7, and 6. All right, and then they ask us to write down those cities' names. So if I just go down the bottom here. Okay, so this is 3.1. All right, so what were those cities? If we go back and have a look at the table, I'm just going to make a quick note. I'm just going to use the abbreviations. You can obviously write out their full names if you want to. I'm just going to use the abbreviations. So we had Bloemfontein, we had Johannesburg, all right, we had Kimberley, we had Mafeking, we had Nelspruit, we also had Pretoria, and we had Polokwane. Okay, nice straightforward question to get you going, to get your confidence up. Okay, let's now have a look at then 3.2. All right, 3.2.1 asks us to work out the maximum temperature, which is labeled as A in the table for Durban. Now, this is such an awesome question. Okay, this one, this over here, this is what we're looking at. I'll just quickly highlight that for you. Okay, so we're looking, let's try that again. Okay, we're looking at that value over there. Now, this is such an awesome question because normally what happens is they ask you the straightforward version. They give you all the values and they ask you to calculate the mean average. What they've done in this question is they've given you the mean average and they're now asking you to work out one of the values that belong to the data set. Okay, so it's just a slightly different way of asking the question, and it's such a nice little twist because it's just so much more exciting than the boring straightforward version that we always give to you. All right, so let's have a look at what they say. They tell us that the mean average maximum temperature is 25.6 degrees Celsius. Now, that's the key, which means that hopefully you'll remember how to calculate the mean average. Mean average means we add all the values together and then we divide by however many numbers that we have in our data set. So we're dealing here with 10 towns and cities, so obviously we're going to divide by 10. And then we know that the answer is going to be 25.6 degrees Celsius because that's what they've told us. So we're going to use that information and we're going to work backwards in order to find out this missing value that they've given us here, this missing A. Okay, so going down then, let's work it out. Okay, so question 3.2.1. So they've told us, as I said, that the mean average, okay, the mean or the average, they like to call it either, is going to be 25.6 degrees Celsius. We know that to work out the mean, we have to add all the values in our data set and we divide by the total number, okay, of items in our data set. All right, and we said already that the total number of items is going to be 10 because we're dealing with 10 cities and 10 cities or towns, how you ever want to put it. Okay, so if we have a look now and we add all the values, let's just quickly scan back to our table. the maximum values, the 23, the 2, the 21, we're going to add all those values together and the A, and then we're going to manipulate our equation in order to get our answer. All right, so if you're looking at the values, I've already done the calculation, so you can do that quickly. All right, what you should get when you add all the mini values, the 21s, the 40s, etc., you get a total of 219, plus the value for A, the Durban value that we don't know, that's what we're trying to figure out. And I'm dividing by 10. Can you remember why we're dividing by 10? Because there were 10 cities and towns, so that's 10 numbers in our data set. All right, and we know that the answer is going to be 25,6 degrees Celsius. Okay. So that's the crux of it. So now that we've got into the question, now it's just a case of manipulating the formula a little bit in order to solve for our missing value, which is obviously A. Okay, so to get A on its own, we need to do opposite operations. So at the moment, we're dividing through by 10. So the opposite of dividing by 10 is to multiply by 10. So on both sides of my equation, I'm going to multiply by 10. So 25,6 multiplied by 10, you can do that on your calculator, or you can just move your comma, because that's what we were looking at earlier with some of the conversions. So you're looking at 256. So over here, I've multiplied by 10. And the reason why I'm multiplying by 10 is so that I can get rid of that denominator and be left with 219 plus A. All right, last bit. I want to get A on its own. So A is being added to the 219. So the opposite of adding 219 is to subtract 219 from both sides. So on your calculator, all right, if you take 256 and you minus 219, you get an answer of A being 37. Now, what is that 37? Remember, A stands for the value, the maximum temperature in Durban. So we need to have a unit included in it, otherwise it doesn't mean anything. And remember, Maths Lit is all about the context. You need to understand the reason why we do these things is because there's a story behind it. Okay, so that's obviously why we're putting in the degrees Celsius. All right, awesome question, because as I said, it's not your straightforward version of calculating the mean. It's given to you, and then you need to kind of work with it and try to manipulate the formula a little bit. So it's a really, really nice question that you can obviously, if you understand it and you can get the crux of it, I think you'll really enjoy it if you see it in your next paper. Okay, moving on. All right, 3.2.2, the median. The median of the maximum temperatures. Now, there's different types of averages that you should know about in Maths Lit. You should know about the mean average, which is the one we've just calculated. You should know about the median, which is the one that I'm going to have a look at now. And then the third one that you have is the mode. Okay, now the mode obviously is the one that occurs the most often, so we're not dealing with that one. The word median, the way I try and get my learners to try and remember it, is mid, okay, the middle number. All right, so if you're looking at, where it says median, if it can remind you, we're looking at the middle number in your data sets. Okay, so let's then have a quick look at our information. Once again, remember that we're dealing with the maximum temperatures. Make sure that you don't get confused, because obviously the minimum and the maximum temperatures are there for you. So you just need to make sure that you read your question very carefully about what they're asking you to calculate. Okay, now, maximum temperatures, they've told us that we've got Bloemfontein, Cape Town, etc., and they've got them all listed there. Now, the most important part about calculating your median is obviously that you need to make sure your data is arranged from smallest through to biggest, okay? Generally speaking, in a paper one type of question, they might give you the data already organized in that order, but in paper two, you can pretty much guarantee that you're going to first have to arrange that data and then find the middle number. Okay, so if we have a look at the information, we've got 10 numbers there, and we need to just quickly arrange these so that they're from smallest to biggest. Okay, so I'm just going to go and cross them out as I go. So starting with the smallest number, I'm just going to write them underneath here. Okay, there's the 21. Then we've got 22. Okay, we've got quite a few of those. There's 4 22s. Okay, then we've got 23. And another 23. And then we've got the 24. And then the last two values, we worked out A already. A, we said, is going to be 37 degrees. So I'm just going to write that there, or I'm going to put it over here. Okay, one moment. All right, 37. And then the last value is 40. Okay, so we've arranged our data, so please make sure that when you are doing this in your question paper that you list your data in ascending order from smallest to biggest, because you get a mark for it. Okay, so don't do it on your question paper, do it in your answer booklet so that the marker can then see that you know to arrange it from smallest to biggest. We're dealing with 10 numbers in our data set. So if there's 10 numbers in our data set, then that means that we're going to find the average of the two middle numbers. Okay, so if we have a look at our data, 1, 2, 3, 4, 5. So between the 5th and the 6th numbers, that's where we're going to find our middle. Okay, median, middle. Okay, just reminding you again. So to work out our median, we're going to have to work out the average of the 22 plus the 23. Okay, so let's do that quickly. Okay, so let's just quickly finish this question. All right. I'm just going to do it over here. All right, so we're going to have a look. This is 3.2.2. As I said, please list your data, write your data out in their ascending order now that you've worked that out. So the median, it's going to be the average of those two numbers. So the two numbers that we were looking at was 22 plus 23, and then we divide it by 2, okay, working out the average of the two, which means that our median is going to be 22.5 degrees Celsius. Okay, so also a slightly difficult question because it's not an odd set of numbers, it's an even set of numbers, so you need to know that the median is going to be in between those two numbers, and then obviously when you know that, then you can work out the average of the two. Okay, we're going to go quickly to a short ad break, and then we're going to come back and have a look at the rest of that question. We're busy at the moment with question 3 out of the February-March supplementary paper from this year. It's paper 2. So let's just pick up from where we left off. We were looking at, in 3.2.2, we were looking at how to calculate the median. And I'll remind you again, median meaning middle. Okay, so we looked for the middle numbers. So we had a data set that had 10 numbers in them, which is the reason why we obviously found the average between the two middle numbers, that being the 22 and the 23, added together, divide by 2, and that gave us 22.5 degrees Celsius. Okay, so picking then up at question 3.2.3, let's have a look at what the question says. It asks us to calculate the percentage of the towns and cities that had a maximum temperature that was greater than the median. So now you've got to take the value that you calculated in 3.2 and use that in order to find your new set of information. So the percentage of the towns and cities that had a maximum temperature greater than the median, reminder the median again was 22.5. So let's quickly then have a look at which ones are going to be greater than that. Okay, I'll give you just a second just to have a look at the data before I actually start circling. So we're looking at the maximum temperatures, and we're looking for the ones that are above 22,5. Okay, so I'm just going to circle them as we go then. So Bloemfontein's got a maximum of 23. Then we've got our Durban value, remember, don't forget about that one, even though we've left it out here. So this is the 37. Okay, that's the 37, so we're going to circle that one as well. We've got 24. Then we've got Mafeking, that was 23. Muzina, which was 40, and then the other three are below 22,5, so we're not going to include those. So we've got 5 towns out of the 10. So nice, easy conversion. They're asking you to work out the percentage. So 5 out of 10, hopefully you'll recognize that as being a half. Okay, so then let's write that down. Right. So 5 out of 10, so this is question 3.2.3. 5 out of the 10 as a percentage, so we're going to multiply by 100 over 1. So if you work this out on your calculator, or you can just do it in your head, you will know then that that is 50%. In other words, half of the towns had a maximum temperature over the average of 22,5 degrees Celsius. Okay, question 3.3. Hope you got that. Hope you're still with me. Question 3.3 says the following. All right, would the maximum temperatures best be represented by the median or the mean, and justify your answer? Okay, so let's just unpack that question. It's asking you to make a decision about choosing either the median or the mean and saying which one is a better representation of the data that's given to you. Now, understanding that we have 3 different types of averages. You know about the median, you know about the mean, and obviously the mode is the other one. So all 3 have a place, and now we need to understand why they're asking me this question about choosing between the median and the mean. Okay, so I'm just going to make a note of that then. So as I said to you just now, we have 3 types. We have the mode, we have the median, and we have the mean. Okay, this one we're not dealing with. If you had to, you'd have to pick the number that occurs the most often, but we're not dealing with that one because it's not part of the question. The median, which we've now calculated, the median was 22,5 degrees Celsius. And the mean they've given to us as being 25,6 degrees Celsius. Okay, so we need to choose either the median or the mean, and choosing which one is a better representation of the data set that's been given to you. So let's go back and have a look at our data set and then decide for ourselves which one we're going to pick. Okay, so if we look at the values in the data set, 23, 22, 21, 24, the 37 for Durban, 23, 40, 22, 22, 22. If you just look at those numbers, you should be saying to yourself, well, if I look at my mean average is 25,6. That's quite high in comparison to the other numbers that are in the data set. Whereas the median average that I've calculated is 22,5. That's very close to the others. 22,5, only 0.5 degrees off the 23. So that to me would be a better indication. If I had to pick an average to represent the data, I would choose that one because all the data values are closer to that number. And that's ideally what the question's actually asking you to write down. So if we just look at the mark allocation for this question is a 3-mark question, which means that we need to give the marker 3 bits of information as to why we are deciding to choose either the median or the mean. Okay, so having a look then, we said already that I would choose then that the best one would be to work with the median, and that is because the 22,5 is closer to the rest of the data values. Okay, so why wouldn't we choose the mean? Well, firstly, the mean is influenced by very high values in the data set. Okay, which high values am I talking about? You'll remember that Durban's temperature came out to be 37 degrees Celsius, and the other temperature that was quite high was Muzina, and that is 40 degrees Celsius. Now, those 2 values are going to influence your mean, because your mean, you have to add all your values together and then divide it by 10. You have to include those very high values. And because of that, that's obviously going to influence your mean. It's going to make it slightly higher. It's like me saying to you, if you had, let's say we were looking at the average of your class. Let's say your class wrote a test and you had to calculate which was the better average. If you've got an extremely smart person in your class who's going to get 100% for their exam, their mark is going to bring your class average up because of it. Okay, so this is the problem with the mean, is that it's influenced by these very high values. We call them outliers, by the very high values and low values. In this case, we didn't have any low values as such, but we had those two very high values that are obviously then going to increase that mean by just that little bit more. So that's the one reason why we're saying we're not going to choose the mean. Okay, so the mean's influenced by very high values. That's the one reason why we wouldn't pick it. And then just having a look then at the reason why we would choose the median. Okay, the median would be better, and our reason for this is because the other values, the other values in the data set are close to this. Okay, take a minute just to have a look at the language that I've used in this question, because obviously when you're answering these questions, you need to kind of get into the vocab of it. You need to kind of get the words that you need to use in order to answer these questions. So words like influenced by very high values, remember, write that down somewhere. Put it down somewhere that so you can remember it and you can use that kind of language in your question. Why did I choose the median? Because the values in the data are close to that value. So using words like data are close, those are good words to use. It's good terminology to use when answering this question. Okay, I'm going to answer just one more, and then we're going to go to, then Peter's going to be back. So let's just quickly have a look then at the next part of the question. The next part of the question asks us to draw a bar graph. Okay, so they tell us that the bar graph showing the minimum temperatures of the 10 towns and cities has been drawn on Annexure C. So let's just quickly have a look at that. Okay, that's been given to you. That would be given to you on your annexure at the back of your question paper. And you can see there they've got all the 10 towns and cities, and they've put the minimum temperatures on that graph. Okay? The question now asks you to, it says, draw a bar graph representing the maximum temperatures of the 10 towns and cities on the same sets of axes. Now, why would we do that? Why would they already put the minimum values in and then ask you to draw the maximum? Well, the most obvious answer would be to make a comparison between the maximum values and the minimum values. Okay, so I'm not going to do that. What is quite nice, though, thankfully the examiner was really nice to you, is that the scale that they've given to you in that, on that set of axes is really nice. Okay, let's quickly have a look at it. It goes up in 5-degree intervals. The maximum values are 5-degree intervals. And then they've even indicated little 1-unit lines in between. So you couldn't ask for a much more easier scale to work with. So you can thank, as I said, if you see the examiner, make sure that you thank them for giving you such a nice graph. All right, I'm going to quickly skip and show you what the graph would look like. Okay, this has already been done for you. So this is now comparing the minimum and the maximum temperatures. Now, you're probably looking at that and saying, well, why isn't there a gap between the two values? And that's a good question, because bar graphs, you've probably been drummed into your head by your maths teacher that bar graphs have to have gaps. All right, and that's true, they do have to have gaps, but this is a comparative bar graph where we're comparing the minimum and the maximum temperatures. So where we've got the minimum and the maximum temperatures of that one particular city, we're putting them together and then we're leaving our gap. Okay, so yes, we always try and drill you with the difference between a bar graph and a histogram. In this case, because it's comparative, I'm not putting a gap in between those two values. I'm putting them right next to each other and then leaving my gap in between the 10 different cities. Okay, so the last thing that we're going to have a look at then is the question then that links to this graph, and that is they ask us to have a look. This is 3.4.2. Which town or city had the greatest difference between its minimum and maximum temperatures, and show all your workings? Now, why are they saying show all your workings? They're saying showing all your workings because the majority of the people would probably just want to guess. And guessing is great, but it's not going to get you 4 marks. So you need to guess intellectually and then show me why you chose the values or the towns that you did. So let's have a look then at the graph. They're asking us to look at which city or town had the biggest difference between its maximum temperature and its minimum temperature. So if you just look at the picture, I'm not looking at the table, I'm not looking at any values, I'm just looking at the picture, all right, because I prefer pictures to numbers anyway. If we look at the difference between the maximum bar and the minimum bar, we're looking for the one where there's a big difference between the two. So the most obvious ones that you can hopefully see if you have a look at this graph is if you have a look at Durban and if you have a look at Messina. You can see there they've got extremely high maximum temperatures, and then their minimum temperatures are kind of average. They're nothing exciting. But that to me looks like there could be a great difference. But then just be careful. Have a good look at the other ones just to make sure that you haven't missed any of the other ones. And if you're not sure, go back to your table and quickly jump on your calculator and work out the difference between the two. So let's have a look then at Durban and Musina. So their values. Okay, so from the table now, if I just go back, I'm going back to the table that they originally gave me. Right? We're looking at the Durban values and we're looking at the Musina values. So we want to know which of those towns had a bigger difference. Now, what does the word difference mean? Difference? Subtraction. In other words, they want you to subtract the maximum temperature, the minimum temperature from your maximum temperature. So the 37 was over here, that was our Durban value. So if I first work out Durban, right, so our Durban value, and then we're going to have a look at Musina. Okay, so our Durban value, our maximum value for Durban was 37, and our minimum value for Durban was, what was our minimum value? 15. And then our Musina was 40 was our maximum and 20 was our minimum. So if we quickly work those out on the calculator, all right, 37 minus 15, you can do that. That's going to give you an answer of 22 degrees Celsius. And the difference in the Musina one will be 20 degrees Celsius. So out of those two values, which one had a greater difference between the maximum and minimum? The obvious answer then is obviously going to be Durban. Okay. All right, I think we're going to leave it there. So let's just quickly just sum up kind of what we've done. So just a couple of things to think about and remember. You need to know the difference between your median values, your mode values, as well as your mean averages. And then remember just to take a moment just to look at the question and make sure that you don't get yourself confused with two sets of information given to you. Make sure that you're very careful about your which ones you choose, your values that you pick. And then I think you'll be okay. So hopefully that's helped you just to kind of get your head around some of the data handling types of questions. Peter's going to be back after the break with another question that he's going to work through. So good luck for the rest of your year, and we're going to quickly go to an ad break.
Claire spent some time with us now going through a bit of stats, and I thought what we'd do is I'm just going to recap a little bit and then look at another one or two questions with stats. So let's have a look. Now in stats, there are basically 4 fundamental things we've got to know about. right? Let's have a look at the screen. The first one is this thing called, there we go, this thing called mode. Now, I'm writing the word like this with M-O large for a reason. The next thing we're going to look at is this word called median, and again, I've got a big MED for a reason. Then we were looking, or we will look at something called the range, and I'm making my G like this again for a reason. And then finally, we're looking at something called the mean. Now, I want you to know that with the mode, the median, the range, the mean, these are things we've got to know about. We can't do stats unless we know what is a mode, what is a mean, what is a range, what is the median, okay? And sometimes we know what they are, but we get kind of confused. And so this is the way I put it to my students, and you might think it's a little bit daft and crazy, but you know what? You won't forget it. Let's look here. Mode, okay? Now you can see I've got capital M-O. Now mode actually means most. Can you see that? Mode, most. Right? Now median is the same thing as middle, if I don't know how to spell properly. Right? Range, now if you look at the way I've drawn this G, it's a long line. There's a value here, a value there. So range is actually my highest value minus my lowest value. So there's like a long line here. We've got a value over here, it's a low value, a value over there, it's a higher value, higher minus low. Mean, well, mean is basically when we take a group of figures, add them all up, and then divide by the number of figures we got. Now that's kind of complicated, and that's just a mean kind of question. And so I say that's how we remember what mean is. Let's go through it again. Mode, most. Median, middle, spelled wrong. Range, the highest minus the lowest. And then mean is dealing with a whole lot of figures that are actually quite ugly to deal with. So let's apply this now to a question that I'm taking from a paper 1. Now Claire's quite brave. She took a question from a paper 2. I know, my Gideon, some of that can get quite complicated. But paper 1, straightforward, basic, and we're going to look at the basics. So let's have a look at this question. Two small companies, Lath Fitters, a cupboard making company, and Mango Computech, a computer company, compared the number of number of days sick leave taken by employees of their respective companies in 2008. Lath Fitters employed 12 workers who took the following number of days sick leave. Mango Computech employed 12 workers who took the following number of days in sick leave. Now, earlier on, I said to you that we were having great fun here because we were doing Maths Lit. Well, there were two chaps that were also having great fun. They went off to a braai, and at the braai they were sitting around braaiing their meat, and they opened up a Coke and drank a Coke, because that's what you drink at a braai, Coke. I hope I'm getting paid for representing Coke. But nevertheless, there we are, they're opening up their Coke, and they drink. And the one guy says to the other guy, "What do you do?" And he says, "You know, I manage a company." And the other guy says, "Strange enough, that's what I do too. But I have a problem with some of my employees. Some of them take a lot of sick leave." And the other guy says, "You know, it's strange that you should say that. Some of my guys do exactly the same thing as well." So they compare figures, because what else would you do at a braai but compare figures? So that's what they're doing. So let's have a look at these figures. Here they are. Lath Fitter says, "I've got 12 workers." And Mango Computech says, "Strange, I've also got 12 workers. These are the number of days they've taken off this year so far." And Mango Computech says, "And these are the number of days my guys have taken off. I've got 2 healthy fellas, and I've got one fella here that's like really pushing the limits." Okay. Now, based on this, let's do a little bit of stats. Like I said, we're just touching on the basics here. Now, question 1. Determine the module number of days sick leave taken by the employees of Lath Fitters. Now, folk, I want to say this to you, that the one goal of an examiner is this. Do you know the difference between mode, mean, and median? And do you know what the range is? Now, he just needs to ask that question once. He doesn't need to ask it twice. So if we look back here at all the information given to us, you will see that we have a set of information, a set of information. No examiner is going to say, find the mean of this information, now find the mean of that information. Because if you can find the mean of one set of information, you can find the mean of another set of information. And likewise with mode. We would ask you to find the mode of one set of information and not the other. Okay? Because if you understand what a mode is, in one part of the question, you can do it again. If you don't understand it, you're not going to be able to do it in another set of data. So let's look at our question very quickly. Determine the module number of days. Now, oh my giddy aunt, we've just been talking about things like mode and median and all that, and suddenly we come up with this ridiculous word called module. Okay, now, module is basically what the examiner is saying is, what is the mode number of days of sick leave? Okay, so first of all, we're dealing with life fitters. So we look at this set of information and we say to ourselves, what number is coming up the most? Now, if we look at it, I've got a 1, a 2, a 3, a 3, a 8, a 8, a 8, a 8, a 9, a 9, a 10, a 10. The figure that comes up the most is 8, 8, 8, 8. We would then say my module number would be 8 in this situation. Our next question says this. Determine the range of the number of sick days or sick leave taken by the employees of Mango Company. Notice we're not asking now for the mode of the next company, because as I explained, if you can do it with one set of data, you can do it with another set. So let's have a look. The range. Do you remember? The highest figure minus the lowest figure. So we're going to look now at Mango companies because we're dealing with them. So let's look at this set of information. And let's forget about this set of information now. We don't need to worry about it. This is what we're dealing with. The range. The highest figure minus the lowest figure. My highest figure is 10. My lowest figure is 0. So what's my range? Well, that's simple. It's going to be 10 minus 0. And 10 minus 0 would be 10. Right. Determine the median number of days sick leave taken by the employees of Mango Company. Now again, folk, we are going to be dealing with this set of information right over here. Okay? So, to find the median, now I want you to listen carefully because this gets very frustrating when we set a question in matric and people know what median is, but what they fail to do is put the information or the data in order. So what we do is we look at our information, we take all this rumble jumble of figures and we arrange it from the lowest right through to the highest. Let's have a look here. Here's all my data. Now I want to say something. The person who set this exam is a lovely, lovely, lovely fella because he's set all the data in order already. Can you see that? 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 8, 10. It's saving you doing that work. Because sometimes an examiner could easily give you 0, 10, 9, 4, 3, 1, and you look and you think, oh my word, where do I begin? This guy's been very, very nice. But I want to stress this. This question's taken from a paper 1. When it's taken from a paper 1, you can expect to have an easier question. Not like the kind of questions that Claire just gave us. Okay? Simple, basic. So let's have a look at that. Now what I'm going to do here is I'm going to take these figures and I want them in a row. So I'm going to cheat a little bit and I'm going to say I've got 0, 0, 1, 2, 3, 4 and I'm going to put this set of figures right next to these ones. 5, 6, 7, 8, 8, 10. And I'm going to pretend that those are not there. Okay? So I've got 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 8, and 10. Let's find the middle one. So to find the middle one now, we're going to cross some figures off and work our way through to the middle, disregarding those figures on the end. back to our screen. So we're going to say, let's cover up that 0, that 10, that 0, that 8, that 1, that 8, that 2, that 7, that 3, that 6. We have a number in the middle, folk. In fact, let me correct it. We don't have one number, we got two numbers. So life now is getting a little bit complicated. But not really, because as Claire explained to us before, if I have two numbers in the middle, I'm going to find the mean of those numbers. So all I'm going to do is this. I'm going to say, right, I had a 4, I had a 4, I had a 5. I want to find the mean of them. To find the mean, we add and we divide by the number of figures I've got. So I'm going to land up with 9 over 2, which, as we know, should be 4.5. If you don't get 4.5, throw your calculator away and buy yourself a new one. Next question. Now, calculate the mean average number of days sick leave for the employees of Mango Computech. Round the answer off to the nearest whole number. Okay, so we're looking at Mango. We're going to make sure our figures are visible. There they are. And what we're going to do is calculate the mean. To calculate the mean, we are going to say, I have got 0 plus 0 plus 1 plus 2. So it's like saying 0 plus 0 plus 1 plus 2 plus all those other figures right up to 10. And I'm going to divide it by the number of employees I have. How many employees do I have? 12 employees. So we're going to go and say, right, let's divide that by 12. We're going to add up the figure, okay? And we're going to get an answer, and we're going to divide that then by 12. Now, I've cheated a little bit, and I've done this before, and I know that all that's going to add up to 54 divided by 12. So we take our calculator, and we say, right, we have 54. We're going to divide it by 12, and we're going to get an answer of 4.5. So we've got an answer here then, 4.5 days. The question says, though, round to the nearest whole number. Folk, you lose so many marks in an exam by not listening to the instructions. And you have to know how to round off. If you don't know how to round off, learn how to round off. Now, 4.5 to the nearest whole number is 5. So we can say the mean number of days that were taken off were 5. Okay, we're going to take a short break. There's another lovely little question I have after this, also to do with our companies, and hopefully we'll be able to have a few minutes just to go through that. We're busy looking at some work to do with mathematical literacy. And just before the break, we were looking at two companies. One called Mango Computech and the other one called Live Fitters. And these were two companies that had a slight problem, or rather their managers had a slight problem in the sense that they had people who kind of got sick. Some never got sick and others kind of got sick a little bit too much, if you know what I mean. And with all the figures, we were doing a little bit of stats. Now we're going to continue with that same theme, okay? But we're going to look at a little bit of graph work. And as yet, we haven't touched on graph work, so this should be exciting. Let's have a look. Here's the question. Each of the two companies employs a general assistant. Mango Computech's general assistant earns 300 Rand a day. If, however, she is at work for less than 1 hour on a particular day, then she earns no salary for that day. However, the general assistant of Live Fitters earns a basic daily wage of 100 Rand, plus an additional 30 Rand for each hour worked. Let's have a look. The formula used to calculate the daily wage of the general assistant of Live Fitters is given as follows. He gets a daily wage of 100 Rand, plus he gets 30 Rand for the number of hours that he works. Okay? So now what we're going to say is this. If I go to work and I work for Mango Computech, I'm going to get 300 Rand a day. Now that's phenomenal. I'm going to get 300 Rand if I work for an hour. 300 Rand if I work for 2 hours. 300 Rand if I work for 3 hours. It makes you wonder why you want to work so much. Why not just work for 2 days and get the 300 Rand? But nevertheless, they have the structure in place that says you're going to get 300 Rand for the day, irrespective of the number of hours you work. However, you've got to work at least 1 hour. If you don't work an hour, we're not paying you. You can't even work 59 minutes, we're not paying you. 1 hour, that's the rule. And after an hour, you're getting 300 Rand for that day's work. However, on the other hand, the Live Fitters says we're going to pay you a little bit differently. We're going to pay you 100 Rand for every day you work, plus 30 Rand for the number of hours you work. Now we have a wonderful table here. Let's have a look at it. The number of hours worked, no hours, 1 hour, 4 hour, C hours, 7 hours, 8 hours. The wages earned. Okay. Now, the first thing I want to say is this, that sometimes examiners can make a mistake. And they're allowed to do that because they're human beings. Now, if you look at this question over here, this was a question that came up, and this was not supposed to be 300 Rand a day. It was supposed to be 310 Rand a day. And you'll see that figure coming up in these values. No hours worked, you're not getting paid. You work 1 hour, you're getting 310 Rand. 4 hours, 310 Rand. 7 hours, 310 Rand. 8 hours, 310 Rand. Now, Live Fitters says the following. They've now got a slightly different scenario. Here, you are going to get 100 Rand a day if you work more than 1 hour. So, I'm not working for at all. Here, I'm not working. I've got 0 hours. So what am I going to get paid? Okay? I am going to get paid 100 Rand. But hold on. I haven't worked. How can I get paid 100 Rand if I haven't worked? Well, if we look here, there's a formula. And the formula says you're getting 100 Rand plus 30 Rand per hours. So if I've worked no hours, I'm still getting 100 Rand plus the number of hours I've worked, which are 0, times 30 Rand. Now, 0 times 30 is 0 and 100. So I've got 100 plus 0 is 100 Rand. Folk, that's a wonderful company to work for. You don't have to go to work and you're getting $100. But don't try it too often. I don't know how long you're going to last in the company. But this particular company says, you know, we understand on the odd occasion you're going to get sick. On the odd occasion your kid's going to get sick and you need to take them to a doctor. So when those kind of days arise, you know what, we're still going to give you 100 Rand. But you're not going to get the 30 Rand per hour. So back to the question. What is the value of A? We've just worked it out, 100 Rand. What's the value of B? How many hours, okay, or what's my wages if I've worked 4 hours? Well, let's look at our formula again. We know we're getting 100 Rand just straight off plus 30 Rand per hour. Now we've just said, hold on, we are now working 4 hours. And according to your calculator, you will discover that 4 times 30 is going to give you 120. Add those up, and voila, your salary for that day is 220 Rand. Agreed? So, B, your value, 220 Rand. Now here is the killer question. What is the value of this thing? C. So let's go back to our formula. Our formula states this, that our daily wage, okay, let's go down. Our daily wage is equal to the 100 Rand plus 30 Rand per hour. Okay. We now, according to our question, says you are earning 280 Rand. So if I'm earning 280 Rand, that is my daily wage. Equals 100 plus my 30 Rand per day. And I'm just going to say 30D. Now, let's manipulate the formula. Move things around a bit. 280. When we take the 100 across, we're going to subtract that 100 and get 180 Rand is equal to 30D. So we need to say, how many times are we going to multiply 30 to get 180? And obviously, it's going to be 6. Because 6 times 3 is 18, and 6 days at 30 Rand will give me 180. So back to here, C is going to work out to being 6. Exciting stuff, people. And you know exactly what's going to happen next. The next thing they're going to say, you see all these figures? Put them on a graph. And that's when life starts to get extremely interesting. So we're going to put them on a graph, and I'm going to tell you something now. We have a set of axes. In an exam, you will be given a set of axes. You have to be given a set of axes. And the reason why they give you a set of axes is because you don't want to spend hours and hours and hours and hours drawing the set of axes. Okay? So we give it to you and say, here's the axes. Now go ahead, draw the graph. What I'm going to do now, though, is I'm just going to draw my own set of axes as I explain a few things to you. Please bear in mind, you would not have to do that. So, let's go for it. Here's my set of axes. Now, it's quite hard to do this without a ruler, but we're going to try our best. And what we're going to say is this, that on my set of axes, I'm going to say this y-axis, and I don't like to use the word y because this is mathematical literacy and we don't like x's and y's, so I'm going to say this is my vertical axis. So my vertical axis is the actual cost. My horizontal axis is going to be the number of days. And we know we are working 1 day, 2 days, 3 days, 4 days, 5 days, 6 days, 7 days, 8 days. And we would write those figures at the bottom of our axes. Now, the cost, well, let's have a look at the cost. The cost ranges right from 0 up to 340. So if we were to do this, we are going to say, right, we are going to make a whole lot of costs all from 0 all the way up to 340. Now, folk, it's going to be a lot easier for you because you're going to have a set of axes. What I am going to do, though, on my graph is I'm going to show 310. Right, now, let's have a look at this. If this guy works for no hours, he's getting no money. We're looking at Mango. If he works 1 hour, he's getting 310. If he works 4 hours, he's getting 310. So in other words, my graph is going to look like this. From 1 hour, I've got a straight line. I should have a straight line. There we go. Anything between 0 and 1, we're getting no money. There it is. Let's do it in a different color. Blue. No money, pal. You wouldn't work for an hour. And I'm going to draw the graph like that. So here is the first graph. Let's have a look at my next graph. My next graph states this, that if I work for live fitters, my A is 100. So if I don't come into a work, that's okay. I'm still going to get $100 and I'm just going to put it over here. And then I'm going to plot all those points. And by day 7, what we're going to notice is my graph's going to look like that. Now, again, I apologize. I don't have the set of axes, but I just wanted to make it a lot more, or emphasize a lot more facts to you. Now, you need to say this. Which company do I want to work for? If I work for this company over here, I've got to work at least 7 hours before I get the same money as this guy over here. Whereas this guy over here, he can work for 2 hours and he's getting 310 Rand. If I only work for 2 hours, what am I going to get? Well, I'm going to get a pathetic little amount over here of about 160 Rand. Life doesn't seem fair. But on the other hand, if I am sick, I'm still going to get 100 Rand. Whereas the other guy is going to get absolutely nothing. Can you see that? 100 Rand, here he's going to get nothing. But folk, we'd like to believe that everyone works a good 8-hour day. And if you work an 8-hour day, let's look at what happens to the graph. This guy over here, he's going to get 340 Rand, whereas this chap stays on 310 Rand. Okay, so we've had a look at stats. We've also now just taken a little bit of time to look at graphs. We're going to take a break, and after the breaks, one of my other colleagues are going to be here just to chat to you a little bit more.
Hi, I'm back. We will be proceeding on what has been done, the mean, the mode, and the range. We had a caller on the line that asked about the mode. Okay. Hi, Ntabiseng.
Hello,
How are you, my love?
I'm fine.
I'm well. Can I just make sure that I got your question correctly? Please repeat it for me.
Okay, I wanted to know that when you find a mode,
Yeah.
is it numbers that appear the most or a number that appear the most?
Oh, okay. So your question is it just one number
Or
or
numbers.
we can have more than a number?
Yeah.
Okay. Ntabiseng, please stay on the line. Are you with me?
Yeah.
Okay. Now, Ntabiseng, I'm going to give you a scenario where we've got different numbers, and then we will be working together on this one. So let's say I've got 3, 5, 7, 2, 9, 3, another 5, 2, 3, and 4. Having all those many numbers in here, now I want you to look very carefully in Ntabiseng. I will be circling the number that appears the most. We are going to do it together. I've got a 3.
Yeah.
I've got another 3. I've got another 3.
Okay.
I look again. I've got a 5. I'm just going to underline it. I've got a 5. I also have a 2 and a 2. Can you see that?
Yes.
Now, if I'm talking about the mode, which number appears the most in this one?
3.
Very good. So in here, my mode will be a 3. So I will write here, my mode is a 3. Now, let's say I've got, in the same, I add another, let's say I take the same 3, 5, 7, 2, 9, 3, 5, 2, 3, 4. I then put a 5. Let's work together.
Okay.
We still have a 3. Can you see it? Another 3, another 3. Are you with me?
Yes.
Okay, my love. Then we have a 5, another 5, another 5. Now, what is happening here is 3 and 5 appears the most. So what is happening, what it simply means is that the 3 and my 5 will be my mode.
Okay.
So the mode,
Both the numbers.
it will be 3 and a 5. So this simply means a mode can be one number or two numbers.
Okay.
It is very rare that they can give you more than two numbers, but it does happen. So meaning a mode is not just only one number. It can be numbers that appear twice. Did I answer your question?
Okay, I'm fine.
Okay. Are you fine now?
Yeah.
Okay, Ntabiseng. Thank you very much for your call, Ntabiseng.
Okay, thanks for your help.
Okay, bye.
Bye.
I'm still going to continue with Ntabiseng's question because I realize that many learners struggle with this. My colleagues have already done it, the mode, the range, the mean. I'm not going to dwell much on that, but I just want to give you a different scenario that it's not always going to appear as 3, 5. It can be bigger numbers, so that's what I'm going to deal about. So if you look at my table here, let me just put it downward. I've got complex A and complex B. Let's just concentrate on complex A. Now, because we are talking about the mode and the median, you can also be asked about the range. Now, my colleague has already said it that if you look at the question, it says, find the range of the number of moviegoers at complex A. He has already explained it. The range is bigger number subtracting a smaller number. But then what I want to emphasize here is, if you look here, it's not been given the way it was given as I gave to Ntabiseng 3, 5, 7, 9. It can be given in that table. So you must find for yourself which one is a bigger number, which one is a smaller number. So if you look in this one, Alice in Wonderland is 10,175. So you try to look, do I still have the other one? So in here, I'm not going to go down in it, but it's just to show you that this one, now for me to find the range, I will be moving. This is the bigger number, which is 10,175. Subtract. Now, which one is my smaller number? You look at the table. Oh, there it is, 200. So that is what a range is. So you will be writing it, that bigger number, 10,175 minus 200 to get your range. So you'll give the answer. So I just wanted to emphasize that so that we stop that confusion of what is the difference between the mean, the median. So the way we have done them today, I know you are not really going to forget it. If you look at the next question, it says here, calculate the mean. Calculate the mean. Now, I just want to emphasize that when you calculate the mean, even if it's these bigger numbers, you must add them all, like it has been emphasized. You add all these numbers. After adding 10,000, all these bigger numbers, you then count simply to say, okay, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Then you divide by 13. So we have that. So to wrap it up, in order to help Ntabiseng and for Ntabiseng not to really be confused, is to say a mode, it's not just a single number. It can be a number or more numbers. But it's very rare, like I said to Ntabiseng, to have 3 numbers. But it can happen. But you know, our examiners, they do really love you, my kids, so you don't really have to panic. So you must always remember, you don't really have to remember the definitions, but you must remember, how do I apply that? So if you look there, so to wrap it up, if you look there, if the question says find the range, it is not always like I gave to Ntabiseng, you know, 3, 5, 7, 2, 9. It can come in a table form. You must remember which one is a bigger number, which one is a smaller number. So to range, you move from, you subtract the bigger, you subtract the small from the bigger number. And if you want the mean, please do not forget, like my colleague has said, the mean is so mean. You just have to add everything that you have been given. You just have to add everything that you have been given. So I hope, Ntabiseng, we did really help you. And I know it's not only Ntabiseng. Please don't forget to contact us at 0861 058 262 so that we can help you more. Thank you very much. I hope you stick to your television because my colleague will be coming to explain more around maths literacy. Thank you very much. We'll be taking an ad break and my colleague will be coming.
Lars, welcome back. We're going to look at one more question in this section, and then we're going to hopefully wrap it up. This came from an email from Godfrey. Godfrey asked us just to have a look at a probability question. So what we've done is we've pulled out one of the questions from the prelim paper, the second paper, and it's question 5.5. It kind of follows on from one of the questions. So I've just honed in on the probability questions. Question 5. The moviegoers buy snacks at the snack counter to enjoy while watching the movies. That's what we all love to do. Snack counter offers a number of choices. So they give you 3 different combos, combo 1, 2, and 3. You'll notice that in all 3 of the combos, they come with popcorn. Then they alternate between either offering you Coke or Sprite, and then the choice of either Smarties or Astros. So the tree diagram shows the possible outcomes for the choice at the snack counter. So the whole point of doing the tree diagram is just so we can organize our thoughts so that we know what options we have available to us. So the examiners have already given you an annexure, and this is basically what your tree diagram looks like. So all you have to do is fill in the blanks. So even if you didn't really understand the concept of a tree diagram, if you just look at what they've already filled in, you should almost be able to fill in the pattern and then hopefully be able to kind of complete the outcomes. All right, so what are we looking at? Firstly, you'll notice that you've got a choice of 3 different combos. Okay, combo 1, 2, and 3. Then you've got a choice of either a small, medium, or a large. Okay, so that's what I'm going to fill in over here. So on combo number 1, I've filled in the large, and I'm filling in small, medium, and large for the other 2 combos. Okay, so those are your options. So you can either have combo 1 in a small size, medium, or large size, combo 2 in a small, medium, or large, or combo 3 in a small, medium, large. Okay, so the outcomes that I'm going to fill in, I'm simply using the abbreviated symbols that they've used in the tree diagram. They often give you the symbols instead of having to write out big long words in order to complete the outcomes on the far right hand side. So my outcomes, I'm dealing with combo 1, and it's coming in a small size, in a medium, or in a large. All right, then I'm going to do the same thing for the other 2 combos. So combo 2, all right, and each one of these comes in small, medium, and large. And then the last one is combo 3. If you're a big Astros fan, then this one will be for you. Okay, and that's what they're asking you to fill in. All right, so question 5.5.1, completing the tree diagram. We've done that. Six easy marks, and all you had to do was simply fill in a few extra symbols. Okay, so really, really easy marks. So if you've never seen a tree diagram before, that's what they're asking you to do. So have a good look at it and make sure that you cash in on those 6 easy marks. Right. Question 5.5.2, calculate the probability of choosing a small combo with Smarties. Okay, so the reason why we do the tree diagram is to determine how many different options we have. So if you have a look at how many are listed, you can see here that we've got 9 options that are available to us. All right? Out of those 9, we calculate in the probability. In other words, I want to know what's the chance of somebody buying a combination that is a small combination and that has Smarties in it. That's definitely one that I would choose if I was picking it. So a small combination with Smarties. So out of the 9, how many of them have that? So now we're just going to quickly have a quick look at the combos 1 and 2 and 3 just to remind ourselves about what the difference between the different combinations were. Okay. All of them came with popcorn. That's the good news. Okay, so each one comes with popcorn. We don't have to worry about that. Combo 1, if we go back to the top, combo 1 comes with Coke and Smarties. Okay, so I'm just going to put there Coke and Smarties. Combo number 2 comes with Sprite and Smarties. So those who are not Coke fans, then this one's for you. Okay, and Smarties. And the last one comes with Coke and Astros. Astros fans, that would be your combo. All right. So out of those 9 combinations, let's just quickly make a quick note next to which ones are the small combinations. Because remember the question? Calculate the probability of choosing a small combo with Smarties. All right. So small combo with Smarties. There's your small combo. There's 1, there's 2, there's 3. However, combo number 3, I'm not going to include that one because that one came with Astros. So out of your 9, okay, the probability, out of the 9 possibles, only 2 of them come with a Coke and Smarties. All right, so that's what the question's asking, 2 out of the 9. Now, they can either ask you to give it as a percentage or a decimal or in words. So in that situation, you'd obviously then have to change 2 over 9 into a decimal or into percentage or into words. Okay, so I'll have a look at that in a minute. I just want to touch on the next 2. Right, the probability of choosing a medium combo with a Coke or a Sprite. Okay, so let's go back to the top to look at our combinations. All right. So now we're looking at medium combos. So I'm just going to put little crosses next to each one of these so that you know that we're dealing with those mediums. Okay. All right. And then they're asking about medium combos with Cokes or Sprites. So it doesn't matter what the cold drink is, it can either be a Coke or a Sprite. So out of that then, we've got 3 out of the 9. So in this case, your answer is going to be 3 out of 9. So the probability out of the 9 combinations, 3 of them would come with a Coke or a Sprite, and they're mediums. And then once again, you can change that into a simplified fraction, which is a third, or on your calculator, okay, on your calculator, if you work out what 1 out of 3 is as a percentage, it's going to be 33,33 recurring. Okay, percent, that's what we're looking at. Okay, and then the very last question, calculate the probability of choosing any combo with popcorn. Okay, now, nice question, because all the combos come with popcorn, which means that what's the probability out of the 9 combinations? How many of them come with popcorn? All of them do. So all 9 out of 9 come with popcorn. All right, so if we had to write that, we've got the probability of it coming with popcorn, and out of the 9, all 9 are going to come with popcorn. As a percentage, that would be 100%. In other words, you're certain to get a combination that's going to give you popcorn. All right, and that pretty much kind of just touches a little bit on the tree diagrams and probability. Hopefully answered your question, Godfrey, if you've kind of given you a little idea of what you're expecting. Not difficult. Don't look at the word probability and think, oh, I can't do the question. They're really, really easy questions if you just get your head around them, and if you just look at your tree diagrams and read out what you need to figure out from the question. Okay, and that kind of wraps things up for now. Stay tuned. We're going to have some more question and answers and more papers out of past, some of the papers, some questions out of the past papers. So you're more than welcome. Don't go anywhere if you're still looking for something else to watch. Just a reminder also, we're going to be back tomorrow. So please phone in with regards to any questions relating to maths, life sciences, English or physical sciences. We're going to be covering all of those subjects in the next few days, all the way through to Saturday. If you missed any of this earlier sessions, they're going to be repeated a bit later. So stay tuned, get yourself some popcorn, Coke and a box of Smarties, and get ready hopefully to learn a bit more from the next few sessions. Thanks for staying with us.